Hello viewers, you are welcome to my channel, Mathematics Made Easy. So in today's video, we are doing a problem on advanced calculus. Okay, we have a summation of n from 0 to infinity of 1 over 2n factorial. Now, how are we going to solve this problem? And what method we're going to use to solve the problem? So in today's video, I'm going to be using a very important and then a unique method to solve the problem, which is the Laplace transform. But you'll be thinking, why am I using Laplace transform? We have a lot of method actually to solve the problem, but today I'll be making use of the Laplace transform to solve the problem. Then how we're going to use the method? It is nothing that is hard. Okay, so stay with me to the end. Take your pen, your book, sit down, and let's learn. All right, 1, 2, 3. All right, guys, so let's solve the problem. Don't worry. For us to be able to solve this problem, what are we going to do? Now, this is what we're going to do. So I can say, let f of t be equal to sum of n from 0 to infinity of t raised to the power of 2n over 2n factorial. That's cool. Why? I was saying let f of t be equal to sum of n from 0 to infinity of t raised to the power of 2n over 2n factorial. Reason why I'm putting 2n here is what? At my denominator here, I'm having 2n factorial. So everything is 3n, you're going to put raised to the power of 3n. So depending on what you have in your what? Your denominator. Do you get what I'm saying now? So at what value of t will make this summation right here be equal to our original summation? Okay, when t is equal to 1, we're going to have what? This summation back. Because when we substitute t to be 1, we're going to have sum of n from 0 to infinity of 1 raised to the power of 2n over 2n factorial. And then 1 to the power of 2n will give us what? 1. So we have this series back. You get what I'm saying now? So nothing is changing here, it's just a matter of what? Manipulation. Alright, now let's move on. So I said let f of t be equal to sum of n from 0 to infinity of t raised to the power of 2n over 2n factorial. So what is the next thing we are going to do? The next thing here is to take the Laplace transform for both sides. Okay, I hope this method, Laplace transform, is not a new method a new topic to you guys. I've talked about it in my videos, okay, like 5 to 10 videos on my channel. So I'm going to send the link in the description so that you can learn more on it. All right, now taking the Laplace transform of both sides, so we're going to have Laplace of f of t is equal to Laplace of summation of n from 0 to infinity of t raised to the power of 2n over 2n factorial. All right, but don't forget we are dealing with t times in t. Times of t. So we're going to take the Laplace transform of t raised to the power of 2n right here. So this will be sum of n from 0 to infinity of Laplace of t raised to the power of 2n then over 2n factorial. That's cool. Now remember from your basic theorem of Laplace transform, like finding some Laplace transform of some functions, especially function in form of this. Okay, remember that Laplace of t raised to the power of 2n is equal to n factorial over s raised to the power of n plus 1. You remember that. But in this case, our n is 2n, okay? So this will be what? 2n factorial over s raised to the power of 2n plus 1. That's cool, okay? That is Laplace of t raised to the power of 2n is what? 2n factorial over s raised to the power of 2n plus 1. So this will be equal to sum of n from 0 to infinity. So instead of me writing Laplace of t raised to the power of 2n, I'm going to write this, which is 2n factorial, okay, over s raised to the power of 2n plus 1, then multiply by 1 over 2n factorial that we are having here, multiply by 1 over 2n factorial. Now, what do you notice? 2n factorial, we're going to cancel out 2n factorial. Okay, so let me clean these parts. Alright, so let's move on. So what we have there now is Laplace of f of t, so which is now equal to sum of n from 0 to infinity of 1 over s raised to the power of 2n plus 1. You'll be wondering our summation has what, deviated from t to s. Yeah. So that is, for us to be able to solve the problem completely, we have to find the summation of this, then take the inverse Laplace of both sides. All right, how do we find the summation of this guy right here? Now, this is what we're gonna do. Okay, so it means that n is starting from 0 to infinity. Now, this means that when n equals 0, so what am I going to have? I'm gonna have s raised to the power of 2 multiplied by 0 plus 1, then plus, this is summation, you add it to infinity. When n is equal to 1, that will be 1 over s raised to the power of 2 into bracket 1 plus 1. When n is 2, plus 1 over s raised to the power of 2 into bracket 2 plus 1. When n is 3, 1 over s raised to the power of 2 into bracket 3 plus 1, then, and so on and so forth. You get what I'm saying now? So we have Laplace of f of t, okay, is equal to 1 over s raised to the power of 2 times 0 is 0, and 0 plus 1 is 1, and s raised to the power of 1 will give us s. Plus, now 2 times 1 is 2, 2 plus 1 that's 3, so we have 1 over s to the third power, plus 2 times 3 is 4, 4 plus 1 is 5, so we have plus 1 over s to the fifth power, plus 2 times 3 is 6, 6 plus 1 is 7, we have 1 over s to the seventh power, plus t infinity. You got me now? Okay, we can see that this is a geometric progression, geometric series. Okay, where the first term is 1 over s, and the common ratio is 1 over s squared, because, don't forget, common ratio is second term over the first term, or it said the third term over the second term, or the fourth term over the third term. You get what I'm saying now? So the common ratio, you say 1 over s cubed divided by 1 over s, so that's going to give you 1 over s squared. Do you understand me now? So the first term here is 1 over s, and the common ratio is 1 over s squared. But remember this. We know that sum of n to infinity is the same thing as a over 1 minus r. Okay, so in this case, your r is less than 1. So whenever your r is less than 1, the absolute value of r is less than 1, we can actually make use of this. Do you get what I'm saying now? So what do we have now? Yeah, our a, which is the first term, is 1 over s. Then the common ratio is 1 over s squared. So we have s infinity, which is a. We have 1 over s over 1 minus r, which is 1 over s squared. Now, we can actually bring this denominator here to this denominator here. So, to do that, we have 1 over s times 1, we have s plus 1 over s squared, we have 1 over s. So, what is the LCM here? The LCM there is s. So, we have 1 over s squared minus 1. Then, if this reciprocates, we're going to have s to infinity is equal to what? S over s squared minus 1. So, that is cool. That is cool. So, it means that this summation right here is s over s squared minus 1. So let me clean all this. Alright, we are getting there. So this is actually equal to s over s squared minus 1. But if you look at this denominator, we can actually mix the difference of 2 squared. Yeah, because remember, if you have a squared minus b squared, this is the same thing as a minus b multiplied by a plus b. Alright, difference of 2 squared. So s squared minus 1 is the same thing as what? S minus 1 multiplied by s plus 1. So that's cool. So I have Laplace of f of t is the same thing as s over s plus 1 multiplied by s minus 1. Difference of 2 squared. That is cool. That is cool. So finally we have Laplace of ft equals s over s plus 1 multiplied by s minus 1. Now, the next thing we have to do, don't forget we need f of t, not Laplace of f of t. So how can we find our f of t? So we have to take the inverse Laplace of both sides. Alright, so now taking the inverse Laplace of both sides, so inverse Laplace, okay, let me write this, inverse Laplace of s over s plus 1 into bracket s minus 1. So don't forget, if you find the inverse Laplace of f of t, so that's going to give you f of t. So this implies that f of t equals inverse Laplace of s over s plus 1 into bracket s minus 1. That's cool. So here's the problem. How do we find inverse Laplace of s over s plus 1 multiplied by s minus 1? Alright, so let me clean this part. Let me clean this part so that we can have a way to solve our problem. Alright, I hope you are enjoying it. So as you're watching, please don't forget to subscribe to my channel. Okay, so don't forget to like and don't forget to comment and also share it with your friend that also love this kind of interesting problem. Alright, so let's find the inverse Laplace of this. Now, if you want to find the inverse Laplace of this kind of function, so what you have to do is to split this into partial fraction. Okay, so I hope you can split this into partial fraction. If not, let's do that together. You have no problem. Alright, so splitting this into partial fraction, so I can say a over s plus 1 plus b over s minus 1 is the same thing as s over s plus 1 into bracket s minus 1. Alright, so next thing you're going to do is to multiply both sides by the LCM, which is s plus 1, s minus 1. So if we do that, we're going to have a into s minus 1 plus b into s plus 1, and they're going to give us s. Okay, so we can say when s is negative 1, what are we going to have? I'm talking about this set s plus 1 to be equal to 0, that is the value of s that will make this function to be undefined, which is what, negative 1. And also here, the value of s that will make this function to be undefined is 1. So we're going to test it one after the other. So for the first one, the value of s here is what, negative 1. That is, when you say s plus 1 equals 0, you have s equal to negative 1. So when s is negative 1, when s is equal to negative 1, so you're going to substitute s to the negative 1 here. We have a into bracket negative 1, plus b into bracket negative 1 plus 1, which is equal to s. So negative 1 here is what? Negative 2, alright? So we have negative 2a, the negative 1 plus 1 here is 0, so b times 0 is 0. And then, which is equal to s, we have negative 1. So you divide this by negative 2 by negative 2. So we have a is equal to 1 over 2. Because the negative signs, they cancel each other. So we have 1 over 2 as the value of a. Then for the value of b, you said when s is positive 1, that is what will make this function to be undefined. That is when you set s to be 1. Okay? So when s is equal to positive 1, so we're going to have a into bracket 1 minus 1 plus b into bracket 1 plus 1, so which is equal to 1. So this is 0, then we have 2b, which is equal to 1, then you divide this out by 2, so we have b is equal to 1 over 2. So that is cool. So a is half and b is also half. So therefore, we have f of t is equal to inverse Laplace of, so that will be writing s over s plus 1 s minus 1. So it's subject to a to be 1 over 2. So that will be 1 over 2 into bracket 1 over s plus 1. Then b is also 1 over 2 plus 1 over 2 into bracket 1 over s minus 1. So that is cool. Okay, so let me clean all this. I hope you are getting it. Alright, it's not something that is hard, it's just you understanding the basic concept of it. So once you understand all the concepts, you know that this is very easy to deal with, easy to destroy, It's a clock hit, alright. So let's move on. So how do we find the inverse Laplace of this? Remember, if you have inverse Laplace of a of s plus b of s, so this same thing as what? Inverse Laplace of a of s plus inverse Laplace of b of s. So we're gonna make use of the theorem there. Okay, so make use of that theorem over there. So we can say that f of t equal to inverse Laplace of 1 over 2 into bracket 1 over s plus 1. Okay, then plus inverse Laplace of 1 over 2 into bracket 1 over s minus 1. So I can actually bring this 1 over 2 out. So I'm going to have f of t is equal to 1 over 2 inverse Laplace of 1 over s plus 1. Then bring this 1 over 2 out. So we have 1 over 2 inverse Laplace of 1 over s minus 1. That's cool. So remember that Laplace of e raised to the power of at is equal to what? 1 over s minus a. And then Laplace of e raised to the power of negative at is equal to 1 over s plus a. So in this case, we are having plus, so that shows that what? a is negative 1. I mean, a here will be what? 1. So we're going to have e raised to the power of negative t. Do you understand? And here we have negative 1. That should have what? You're going to have what? E raised to the power of t. That here is 1. So just substitute a to be 1. So you have e raised to the power of t. You get what I'm saying now? So therefore, we have f of t is equal to 1 over 2. So here we're going to have what? E raised to the power of negative t. Then plus 1 over 2. Here we have what? E raised to the power of t. Okay. That's cool. So remember, we said for this to be true, what will be the value of t? We said t must be 1. So you substitute t to be 1 here. So we're going to have f of 1 is equal to 1 over 2 e raised to the power of what? Negative 2 plus 1 over 2 e raised to the power of 2. Yeah. I mean, sorry, 1. What am I writing? 1. Okay. So therefore, we can actually factor out this 1 over 2. So we have 1 over 2 into brackets e raised to the power of negative 1 plus e. So that is the result to this beautiful problem. So we say this is equal to 1 over 2 e raised to the power of negative 1 plus e. Alright, so that is the answer to the beautiful problem. So if you like this kind of video, please don't forget to subscribe to my channel. Don't forget to like my video. Don't forget to comment. And don't forget to share. Share with your friend. Don't watch it alone. Okay, so thanks for watching. See you next time. Bye.